Here's a paper where the same AI model gets asked the exact same chemistry question twice. Once left to answer on its own, once hooked up to a different kind of database. And the number of citations it just makes up drops from 6 out of 14 to 0. Chemistry question like what electrocatalysts have been reported for CO2 reduction to CO and at what Faraday efficiency don't have a single paper answer. The real answer is scattered across dozens of papers as individual findings about catalysts, reaction conditions, and measured values. Existing literature search tool only return ranked list of whole documents, so scientist or an AI agent using those same tools still has to open each paper, dig out the relevant numbers, verify it, and stitch the answer together by hand. It gets worse with LLMs specifically. When a model is asked to answer from what it already knows instead of actually retrieving something, it can generate a perfectly plausible looking citation that doesn't actually exist. AskCharm changes the basic unit of retrieval from the paper to the claim. An atomic typed scientific assertion pulled out of paper tied to a source DOI and either a verbatim quote or an explicit locator in the document. Plus, structured field like reactants, conditions, and measured outcomes over the shared claim store. The system builds three different lenses onto the same data. A stabilized faceted taxonomy sorts claim by things like reaction type, substance class, and techniques for hierarchical browsing. An evidence graph linked individual claims to each other through typed relationships. One claim supports another, contradicts it, extends it, or derives from it. So you can walk from a single finding straight to whatever agrees or disagrees with it. And the more exploratory living taxonomy organizes papers not by what they are about but by which underlying scientific principle actually governs their contribution. Claims get pulled in through two separate pipelines, a fast, cheap pass over abstracts, and a slower, deeper pass that reads the full PDF and can catch things abstracts usually skip, like stated limitations or surprising results. All of it is exposed through a normal web interface plus a REST API, an SDK, and an MCP server. So an AI agent can query the same claim store the same way a human researcher browses it. At the time of writing, the live index holds 2.4 million claims pulled from 147,000 papers going back to 1925, organized into 307,000 populated taxonomy categories with an evidence graph of over 171,000 types linked between claims. To check whatever those automatically extracted relationships are actually correct, a domain expert hand checked a sample of 148 of those ages. Of the ones that were actually decidable, 143 out of 146 had the correct relationship type, just under 98% precision. To test whatever any of this structure actually helps answer real chemistry questions, the author built a 30 question benchmark across three task types, pulling together scattered conditions, checking how a finding evolved over time, and surfacing outright contradictions between paper, and run the same GPT 5.5 render model through 5 setups, answering with no retrieval at all and grounded in three other existing research assistant tools. What they found, with no retrieval at all, only 88.3% of the models cited the DOIs is actually existed, meaning roughly 1 in 9 of its citations were fabricated outright. Ground the identical model in AskCharm and that number hits 100%. Every cited DOI resolves a result tied only by one of the four competing system tested. AskCharm also comes out ahead on citation density, meaning how many distinct verified source actually showed up per answer. 18.1 per answer, the highest of the five systems, and it gets the best average relevance score for how on topic its answers are, plus the highest share of citation to recent high impact work. The one worked example the paper walks through in details is the straw catalyst question from the cold open left ungrounded. The model fabricates 6 of its 14 cited DOIs grounded in AskChem, which cites 22 sources. Every single one resolves, and the reported numbers come straight out of the original paper's text. AskChem isn't the best system on every measure. One competitor, a closed commercial deep research agent called Edison Scientific, produced noticeably more citation linked quantitative details than AskCharm does, and edges it out slightly on staying strictly on topic. The authors are upfront that AskCharm's angle is different, claim level rather than paper level. The whole index openly released fast enough to browser interactively and usable directly as an agent tool, while still being the system that eliminates fabricated citations on this benchmark. There's a real depth trade-off inside the corpus too. Only 30% of the 147,000 indexed paper have actually been read in full. The rest are abstracts alone, a shallow pass that tends to miss a paper's own stated limitations or keywords. Full text passes turn out to be far more claim rich. So, two-thirds of the actual claims in the system do come from the deeper read, but that still leaves most of the papers in the index represented only by their abstract, and the authors are careful to note that using the taxonomies inside search isn't the same as proving how much it's actually contributing versus the raw search underneath it. That separation hasn't been isolated yet. The system is live right now at askcharm.org. The source is MIT licensed on GitHub, and a CC by snapshot of the full claim index is released on Hugging Face, a rarer case where you can go poke at the actual running system today instead of writing on a promised release. That's the shape of it. Swap search return documents for search return verified atomic claims, and a model that used to fabricate nearly half its citations on a hard question stops fabricating any of them.
Thanks for watching.